Today's lesson is lesson 9-2, which is tables of equivalent ratios. Okay? You already wrote down this vocabulary. Equivalent ratios express the same ratio relationship between quantities. Okay? Equivalent ratios means equivalent fractions. Okay? And last class, we made equivalent ratios by doing this down here, by scaling. Scaling forward or scaling backward. Yesterday we called it scaling up or scaling down, right? So, scaling is the process of multiplying or dividing each quantity by the same number to obtain an equivalent ratio, okay? Now, scaling, that when we're multiplying, that one is a scaling up, okay? Because the numbers are getting bigger. That's called, in this lesson, we're going to call it scaling forward, okay? Dividing, that we called it scaling down yesterday, okay? Today we will call it scaling backward, okay? Now, when we do that, and we organize our ratios in a table, that is a table of equivalent ratios. They call that table a ratio table. And that is a collection of equivalent ratios that are organized in the table. It consists of pairs of quantities that all have the same ratios. So we just talked about multiplying and dividing. And now we have a table that has addition in it. What? So let's see. Here, you guys, this is also creating equivalent ratios. If you add 2 and then add 2 to the next one, not to the original, but to the one before it. See, we're adding the same number on the top and we're adding the same number on the bottom. These two, they don't have to be the same when you're adding, okay? That is creating equivalent ratios. So 2/3 is equivalent to 4/6 is equivalent to 6/9. So here we're going to add 2 cups of yogurt for each new column. We'll add 3 cups of flour for each new column. That is one way to create a ratio table. Now, majority of the time, we're going to use this method right here, okay? We're going to use the scaling to create equivalent ratios. It says, continue the pattern by multiplying each of the original quantities, okay? So we're going to multiply the original quantities by the same number to obtain values in other columns, okay? So the original is 2/3. The original is 2/3. So we're going to, and you guys should be writing this down in your notebook. I would write this one down, this table, the Greek yogurt and the flour. To get to the next equivalent, we take the original ratio and we need to multiply by the same number. So how do I get from 2 to 4? 2 times 2. So I'm going to multiply times 2. If I multiply times 2 up there, then for the flour, we also have to multiply times 2. See? 3 times 2, that gives us 6. Is everybody clear with that? So here, 2/3 is equivalent to 4/6. So now we're going to go from the original again. And how do I get from 2, how do I get from 2 to 6?
By multiplying 3.
We're going to multiply times 3. So from 3 to 9, you'll see if I multiply times 3 times 3, that also gives us 9. So here, 6/9 is equivalent to 2/3. Does everybody see that's the same as what the table is up here? Okay, and then we can continue some more. So here, to get to the next equivalent ratio, what am I going to do to get from 2 to 8?
By multiplying 4.
Times 4. Very good. So here, I'm going to multiply times 4, 3 times 4 down here, also to get to 12. Right, whatever you do to the top, you have to do to the bottom. So, finally now we've got the 2, the original, and we're going to multiply times what to get to 10? Times 5. Not 5 times 5, 2 times 5. Right. So now 2 times 5, that gives me 10. I'm going to multiply times 5 in the denominator. So 3 times 5 is 15. Okay? So all of these are equivalent ratios. So example 1 is scale forward to find equivalent part-to-part ratios. Please make sure you are writing down your title for your example. So in a batch of trail mix, there are 3 tablespoons of peanuts for every 2 tablespoons of sunflower seeds. How many tablespoons of sunflower seeds are needed if you have 18 tablespoons of peanuts? Okay? So the first thing we want to do in our problem is decide what is it we are comparing. So if we're looking at this, we are comparing 3 tablespoons of peanuts for every 2 tablespoons of sunflower seeds. Be careful when you are writing your ratios. It's very important for you to get the order correct, okay? So we are comparing peanuts to sunflower seeds. I'm going to put SF seeds. Okay? And the original ratio is 3 to 2. Very good. 3 to 2. And what are they asking us?
How many tablespoons of sunflower seeds are needed if you have 18 tablespoons of peanuts?
Very good. So we want to know how many sunflowers if we have 18 peanuts, tablespoons. Is everybody clear?
No.
All right. So we want to get to 18 tablespoons of peanuts. Everybody with me? So we're going to scale forward. And remember, scaling forward is multiplying, right? So the first thing we're going to do is we're going to multiply times 2. And if I multiply times 2 in the denominator, for the peanuts, I have to
Multiply for the sunflowers.
right, multiply it by 2 for the sunflowers. So that's going to be 6 to 4. There's my first equivalent ratio. Is everybody with me? So now we're going to, from the original, now we're going to multiply times the next. So this is going to be times 3. And if I multiply times 3 up there, I need to multiply times 3 down there. So that's going to be 3 times 3 is 9. And 2 times 3 is 6. Okay, we're almost there. 18 tablespoons of peanuts, right? So now we have 3. So now we're going to multiply times 2 times 3. Now we're going to multiply times 4 times 4. So 3 times 4 is 12. And 2 times 4 is 8. Okay? Let me get another color. So now, original, we're going to multiply times 5. And then we're going to multiply times 5 down here. So 3 times 5 is 15. And 2 times 5 is 10. Very good. I need to add some more on my table. All right. So now, multiply times 2 times 3 times 4 times 5. Now we're going to multiply times 6. Oops, that goes over there. Times 6. And then times 6. So 3 times 6 is 18. And 2 times 6 is 12. Very good. Now, I do want to let you know, when you're doing this on your own, it's gonna be faster, right? Okay, it's going to be faster because you're not gonna have me talking you through it. So you can just write it down. So what's my answer then? How many tablespoons of sunflower seeds do we need if we have 18 tablespoons of peanuts?
12 sunflower seeds.
We need 12 tablespoons of sunflower seeds. Very good. So let me, I'll just start with the 12 and we'll write, we need 12 tablespoons, TBSP, tablespoons of sunflower seeds. Here, you're going to work on letter B with your table partners. Let me read it so we can get it on the recording. It says, a patient receives 1,000 milliliters of intravenous or IV fluids every 8 hours. How many hours will it take to receive 4,000 milliliters of IV fluids? All right, take 3 minutes to work on that with your table partners. So, first thing we want to know is, what are we comparing? Okay, let's take a look. So it says a patient receives 1,000 milliliters of IV fluids for every 8 hours. So we're doing the IV fluids to the hours. Does everybody understand the ratio? Okay, so we're going to write IV fluids up here, milliliters of IV fluids here, and the number of hours down here. Now, what's my first ratio going to be?
1,000. Yeah, 1,000 to 8.
Very good. This is going to be 1,000 to 8. Okay? What are we looking for?
4,000.
We want to get to 4,000 milliliters of IV fluid, and we want to know how many hours is that going to take. Is everybody clear with that?
Yeah.
So, we want to get to 4,000. Yes, I know you can multiply the 1,000 times 4 to get to right straight to it, but we want to fill in our table. Okay? We want to fill in our table. So, here, to get from 1,000 to the next one, we're going to multiply times 2. Times 2. So that's going to give us 2,000 to what? To 16. Very good. And then, from the original, we're going to multiply times 3. Times 3. So that's going to get us to 3,000 milliliters in how many hours? 24 hours. Yep. And then we're going to get to our next one. So now we multiply times 2 times 3, and now we're going to multiply times 4 times 4. So what's that going to give us? 4,000 milliliters to how many hours?
32 hours.
32 hours. So, very good. So, it's going to take her 32 hours for the patient to get 4,000 milliliters of fluids. And you could even write milliliters here and hours here. So, for example 2, we're scaling backward to find equivalent part-to-part ratios. So it says, to make 3 loaves of banana bread, we will need 9 bananas. We want to know how many bananas are needed to make 1 loaf of banana bread. So what are we looking for?
The number of bananas needed to make 1 loaf of bread.
Right. So we want to know how many bananas are needed to make 1 loaf of banana bread. What is what are we comparing?
6, 7, 9.
No, what in words, what are we comparing?
3 and 9.
we're comparing 3 loaves of banana bread, and we're comparing that to the number of bananas. So here, we're going to write loaves, so the number of loaves, to the number of bananas. Is everyone with me? All right. So now, what is our original ratio?
3 and 9, or yeah, 3 and 9.
3 loaves to 9 bananas, right?
Yes.
Now, we want to get to 1 loaf. How do I get from 3 loaves to 1 loaf?
By subtracting.
Not subtracting.
Dividing.
We're going to divide by 3. 3 divided by 3 is 1, right?
Yes. Easy.
So we're going to divide by 3 in the numerator and the denominator. So that's going to give us 1 here and 3 there. So, how many bananas do we need?
3.
We need 3 bananas.
So then you just top judge to bottom. Always.
Right. For 1 loaf.
That's easy.
Good. All right, so for this example, it says to make a cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. How many cups of sugar are needed when 4 cups of cranberries are used? So again, the first thing you want to ask yourself is, what are we comparing? Right, we're comparing, well, am I comparing cranberries to sugar? Right, sugar to cranberries. You got to be careful how it's written in the problem, okay? So, you need 12 cups of sugar for every 16 cups of cranberries. Now it says how many cups of sugar are needed when 4 cups of cranberries are used. So, what are we looking for? Right, so we're looking for how many cups of sugar are needed when we use 4 cups of cranberries, okay? So, in our table, in the top left, we're going to write sugar, right? So, cups of sugar. And in the bottom left, we're going to write cups of cranberries. Good. What's my first ratio going to be? 12 to 16. Very good. 12 to 16. Now, we want to get to what? 4 cups of cranberries. Okay? We want to get to 4 cups of cranberries. So we're going to start with the 16 cups of cranberries. So, let's go ahead and divide by 2. So we're going to divide by 2 here, divide by 2 here. So that's going to be 12 divided by 2 is 6, and 16 divided by 2 is 8. Okay? So now, I want to get to 4, right? 4 cups of cranberries. So how do I get to 4 cups of cranberries? We're going to divide by 2 again. Is everybody clear with that? So, from here to here, we're going to divide by 2, divide by 2. Hold on 1 second. So, 6 divided by 2 is 3, and 8 divided by 2 is 4. So now, we have 12 sixteenths, 6 eighths, and 3/4. Those are all equivalent ratios. What's the answer to my question? Very good. We need 3 cups of sugar. All right. So this is the end of part 1 of the lecture. We're going to finish this lecture tomorrow. Okay?